Hello, everyone. Yes, it is the real me, the real Pert, coming at you live from his underground bunker here. And this will be your first Algebra 2 online lesson. Joy, joy. I'm going to share my screen with you. That way, I've got my overhead camera here, and anytime I need to talk about things, in our class or the document that you'll be using to access the videos in your assignments, I can go right to that. So I will be up here in the corner, just to let you know that it is the real me. We have a lot to talk about before I do the first lesson, so bear with me and pause the video if you need to go over things or practice the calculator entry material that you're going to need to know. So the first thing, my office hours will be from 7 to 9 o'clock at night on Wednesdays, and I'll put that in our classroom. So you're going to have to come here, and I'm going to delete out every day the old posts and put in the new a new post, which will be the updated document. So this is our class document, and it'll only be this post, one post. And you're just going to get in here and find the stuff that you're going to need to get. So for today, it's going to be these two here, the notes 1 and the notes 2, the first page of those two. We got a lot of stuff in this unit. And then you're going to access this video, which is not posted yet because I'm doing it right now. And then if you want to print out the sheet to take notes along with me, that's great. If you just want to watch the video, that's fine. And then your assignment, and then the solutions. So however you want to do that, probably the best thing is just to pull it up and use notebook paper to do your work. You're supposed to not work longer than 30 minutes to keep our stress level low. I know that with this material, it's going to take longer today and tomorrow. So I put Wednesday in as a break, and that'll be my office hours. If you just want to come on and say hello, ask a quick question, there will not be new material on Wednesdays. And so that'll give you time to get caught up with the first two assignments that I've given for the week. So for our unit progression, we'll have these two assignments, 1 and 2, that you see in the magenta there. Wednesday will be a break, then you'll have assignment 3 on Thursday, and then Friday will be the review, which is like the first practice quiz, and then next Monday will be the quiz. Because we are pretty crunched for time, this is going to be a one and done. So one day, you have the video, which is nice to look back on per, I guess, learning target, and then we will move on. I think that's just the best approach, since you can go back in the video, and I'm going to be very thorough in my videos as I teach. Also, good news, if you participate and engage, you will get credit in this class, regardless of how you are doing. Now, I hope you do well. But this class will not be graded, as all of your other classes will not be graded. And as long as you can provide me evidence that you have completed the quizzes, which my advice to you, take a picture of your quizzes, the 5 or 6 that we'll have, and just keep them until June 5th. Then on June 5th, send me the email of your 5 quizzes, and I will take you at your word that you did those. And I think that's probably the best approach. In between that, it would be great if at some point you interacted with me and either asked me a question or said, hello, I'm doing great, or hello, I'm not getting anything. At some point, touch base with me just so I know that you are engaging. The next very stressful thing is what to do with calculators. So some of you, most of you don't have a graphing calculator, and I realize that, although I will show what to do on a graphing calculator. I think these calculators, the 36X Pros, are great. They are very inexpensive. So on Amazon, I actually went and searched one and put it in my bin. So $19, very inexpensive, and they will do everything we need them to do. They don't graph, but I can show you an online graphing tool called the Meta Calculator when we need it, that will work just great. So I advise this. It's just very simple, and it has where we're headed, a log base button, which is very important. It saves a lot of entries if you, or I guess entry stress, if you need to come up with a decimal in the solution, or you want to come up with a decimal in the solutions. All right, so let's see here. These 2 packets of notes that you see, you're going to need the first page, and on our document, it is the exponential function types notes 1. That's this up here, which I just basically retype to make it a little bit cleaner and put an extra another way the equations can be represented so that you're aware of that. And that's the number 1. Then the number 2 one will need the first page of, especially this one here. So actually in our assignment, the 4 word problems at the end is this first page of your first note packet, and then the 10 solving are, you'll need to refer to this. Once you get the hang of it, you hopefully don't need to refer to those very much at all. All right, so I think I've covered everything. If there is a question, you can email me. I would prefer emails to be on Wednesday because I know, and yep, I'm paid a lot to answer my emails. I get that. I know there's going to be a lot of emails during this time. So if we could stick to Wednesday, if you have questions, that would be great. Although I'll take them on the other nights. I'm just not sure with how long this takes me to do these, that I'll have a whole lot of time to answer you right away on those days, but guaranteed Wednesday. On Wednesdays, I will answer you. All right, so this is the document that I'm going to use to show you our next learning target, which is solving exponential equations. And so what is an exponential equation? An exponential equation is an equation that has a variable exponent, and we need to get at that exponent if we're going to find a solution. And that's what this first page on the notes 2 goes through, is how to get it set up and then how to take the log base on both sides to do these. So I'm going to walk through these 10, and some of them are very simple and some of them are a little bit, you need the experience in practicing the problems to get good with it. And then you'll have your assignment to practice. And this is going to take more than a half hour. And that's where on Wednesday, we can, without having anything new, we can hopefully give you the time to get caught up. So the idea is this: you need to get the equation in this format or this format over on the right. And that's what I call exponential form. So the question is this equation in that format? And the answer is yes. And then once you have it in that format, so a single base, a single variable exponent equals a number on the right or another exponential statement with a single base and a single variable exponent. So it's going to be one of these two, and then it's going to be ready to solve. So basically what you do is you take log base, whatever the base is in the exponent side. Okay, so log base 2 because the base is 2 on the left. And then that's the inverse expression that allows you to solve for x. So actually what happens is that x comes down, then you have, I skipped a step in here, then you have log base 2 of 2. I think I can squeeze it in here. And it's the step that I'm not going to write every time because it's just an assumed thing, that you can see that the log base 2 of 2 is going to cancel out. It's going to be 1. And this exponent expression is brought down as a coefficient in front of the log base 2 of 2. And maybe that exponent is like a 3x or an 8x or an x plus 5, but whatever that is, that comes down. Now, the problem with this is if you have a calculator that has a log base button, you can actually crunch out what this is. And so this is where it's going to take me a little bit longer today. And I will show both of these calculators and then what you can do online without a log base. Actually, there's logarithm calculators online you can use. But on this one, right here where you see ln and log, you'll get to the point where you have, and the same thing's going to be true on the graphing calculator, where you have a log base button and it can crunch out what that is as a decimal, so 3.58. And now to save time, I'm not going to repeat this every time, that set of entries, so you need to take that into your learning. And then on this, you're going to go math, up arrow, twice. So math, up arrow, twice. We'll take you to log base and then press enter. If that doesn't come up like that, you need to check in your mode and make sure that you have math print on. So I think with classic, it won't do it. Let me try it here. So you need to make sure you have the math print on. Yeah, so under your mode, make sure that you have that math print on like that, and then it will do it. So again, math, up arrow twice, will get you to log base, and then you can do 2 and 12 and 3.58. So if you don't have a calculator that will do this, there's something called the change of base formula, and you can then just go online and do this. And so the change of base formula would say this. Okay, that log base 2 of 12 is equal to log of 12 over log of 2. And that's what this is right here. So once you have this, and you don't have the calculator that'll do that, you can go online and enter either one of these. Now, what does this mean? This means log base 10. So when you don't write the base, it's base 10. And when you use what's called the natural log, that means log base E. And so that's what this is here. So you can use either one of those. And if you need to, just go online, really anywhere, and you can type it in. You could go to literally like a search. This is how smart the internet is, and just type in log of 12 divided by log of 2. There it is. Okay, so I mean, you can find these calculators. I'm probably going to hold off on showing you the meta calculator, although it's common sense. You're going to go to scientific calculator and you can look at that and peruse that. But at some point, I'll start to work with that when we need to graph a little bit more. I will start to work with that. I will accept log base 2 of 12. 3.58, we'll take it to the nearest hundreds place. Log of 12 over log of 2, or ln of 12 over ln of 2. These are the exact answers here. And so it's good to do that because Khan Academy, I believe, does that in their work. They just will say, here is the problem, now give us the exact solution. So again, steps, log base, whatever your base is in the exponential statement, you do that on both sides. And then whatever this is comes down as a coefficient in front. And then the log base 2 of 2, or whatever that's going to be, those are going to be the same values. That cancels out. And then you have whatever this is right here, which sometimes it's not just x, like you'll see in the next one here. All right, so number 2, we have to do, it is in the form, and this is important that you come back here and validate that you do have a single base and a single variable exponent. You'll see on problem 4 that's not the case, and that we need to deal with that. I'm going to start out log base 3 of 3 of going like to the second step, this line here, and then you have to do log base 3 of 81. So it takes down the x minus 1. That goes in front. This becomes 1. Now you should try to simplify the log base 3 of 81. That is going to simplify into something very nice. And that is 4. So check it out. If it didn't, you could just leave it as log base 3 of 81. But it does simplify into 4. And then add 1 and you'll get 5. To understand, okay, why is it 4? Is another thing, another way of looking at it, and I really like this in the end the best, is that any exponential can be turned into a logarithm statement, which means the same thing. So log base 3 of 81 equals something means 3 to the something equals 81. 3 to some power x equals 81. Okay, and that would be 4. But you can just, for right now, until we get more practice, just use your calculator to check it out to see if it would work out to be a nice whole number. Notice E here. So E is the natural exponent. It's a special base, and it's how things grow naturally. So if you see that, what to do is you have to do log base E on both sides. Well, what is log base E? Log base E is ln. Okay, so I'm going to write that a few times so that you get that down, but it does mean ln, the natural log. And so on any calculator, you would have a natural log key. That's the first one right here. And 1.61 is that. So again, any of these are acceptable answers for that. So your calculator has a log base E button, and it also has just a log button. Those two every single calculator has. Not every calculator has the log base button, okay, where you can have any base. So note that. That's why sometimes I have to use the change of base and sometimes not. So it depends on what bases we're dealing with. On problem 4, you need to get the problem in this format here, right here. We need to get that. And how is that done? Well, we're going to add 14 to start with. And then we're going to divide by 3. Now we have it into on the left where there's a single base and then a single variable exponent. And now we got to do log base E on both sides. And understand that log base E is just the natural log. And remember that whatever that exponent is, that comes down in front we're looking at this again, this work right here. And then this drops out. So here is the and in time, I'm going to stop writing log base e, and you need to know that that is ln. So 2.12 is this one. Okay, when you crunch that out. All right, so number 5, notice that we still don't have a single exponential statement on the left, and you have to try to get that. And what is done here is we're going to use a rule of simplifying exponents, and it's likened to if I said do x to the 4th times x to the 3rd. You would say that's x to the 7th. Then you add those exponents. So that's what we're doing. We're adding the x and the 3x. And now we have a single exponential statement on the left. And we're going to do exactly, it's going to be log base 2. So how do you know what base is in the log? The base is the base. What's the base in the exponent? 2. So 4x will come down, log base 2 of 2, and then log base 2 of 10. So again, that drops out. And then you would divide by 4 to get your final answer. And if you don't have the log base button again, you would write it this way. Log of 10 over log of 2, and then the 4 is in the bottom. I will accept either one of these answers and also the decimal version of 0.83. So all of these are acceptable. I like the first one the best. This is, again, if you don't have a log base button, notice how that works. And then the decimal form. All right, speeding up a little bit. So first thing here is we need to divide by 2. Notice the base of e again. And in dividing by 2, that's 22 and a half. And now we got to do log base e on both sides. This is probably the last time I'm going to show log base e, and we're going to start doing ln. So the 0.5x would come over in front. Don't forget to bring that down in front. That's what allows us to get at x. So that drops out, 0.5x. And then divide both sides by 0.5. And you will have it. And that is 6.23. Problem 7 is the first problem. Problem 7, 9, and 10 are going to be this side of things where we need to create the same base on both sides. And I think I'm going to do problem 9 first, then come back to 7 because 9 is actually easier than 7. And then we just simply remove the logarithms out because they're both going to cancel on each side and set the exponents equal to each other. So problem 9 first. So notice we have a single base on each side with a single variable exponent. So we're just going to drop down and set the exponents equal to each other. I want to say this, if we did not have a base of 3 on each side, we need to try to get a base of 3. You're going to go with the smaller base when you try to make the same base. So then divide by -3. Pretty simple there to do. Let's go back to 7. Now the problem here is we don't have the same base. So we have to make the right-hand side into a base of 4. And this again is done with rules of exponents. So 16 is 4 squared. And then we have 4 squared to the x power, which is 4 to the 2x power. You multiply exponents. So it's, if you had these problems, x squared cubed, x to the 6th, you would multiply exponents. And now you have a base of 4 on both sides, and you just simply take these equal to each other and then solve out for x, and you would get x is -1. I did that the hard way, subtract x to the right, leave -1 on the left, but x is -1. And notice number 8, we're back to just the exponential on the left side, and we're good to go. We're going to do log base 8, bringing down the x as a coefficient in front. So log base 8 of 512 is acceptable, and that is equal to 3. Let me just put that up here for a moment. So in looking at this, this means that 8 to the 3rd power is 512. So that's what you're answering. And that all has to do with getting used to this conversion right here. These really mean the same thing. They're not the same graph, but they really mean the same thing. And then on 10, notice, this is the hard one, that we have the base and a exponent situation on both sides. So it's going to be this here. We have to create the same base right here on each side. And it's going to be a base of 2 on each side. So we have to go 2 squared. That's going to be 2 to the 2x. So I have a single base of 2 on the left. You're going to go with the smaller one. On the right-hand side, I do not have a single base of 2. But what you can do again is call upon rules of simplifying exponents. So what did I just do there? If I said x to the 4th divided by x squared, you would subtract exponents. That's literally what I'm doing, the 1 minus x. So I'd consider this a tier 3 level problem in being able to see that. And now we're ready to take each exponent equal to each other. Okay, and then solve. So 3x is 1, and then x is 1/3. That completes the solving. The important material are problems like this. You're going to take log base, whatever the base is, and a base of e means log base e. That really means the natural log. And also be aware of the change of base formula if you don't have a calculator that does log base. So log base 2 of 12 means log of 12 over log of 2. This will take us into the word problems, and that's the other document in these formulas here. Let me zoom out. And we're going to just go left to right, literally, and using all of these. The best thing to do is to try to write the formula based on the description. And then on part B is where you're going to do log base on each side to solve for an x given a y instead of using your calculator table. Why 2? Whereas we just had 1 on my old notes, because the second one is another way to write the top one. And it depends on the textbook, and the Khan Academy probably does the bottom one. And just so you're aware of that, yep, that does spell my last name, not because of me, but because those are the variables that are chosen. All right, so 11a, I'm going to still use the y equals just because I like the fact that you can put that into your calculator and look at a table. So there are 4 guppies initially, that's your A value, and it doubles every day. So B is your multiplier. And that's, in this type of problem, we've done these in the past, that's the value of B. Whatever tripling, halving, whatever that is, that's the value of B, and that's your multiplier. After 3 days, so now you're going to just put in 3 for X, and you're going to crunch out how many guppies. So obviously the number of guppies will not keep doubling over and over and over. That's why I limited it to 1 week. So how many guppies, or how many days the near time have elapsed if the aquarium has 45? So this is where you take the Y equal to 45, and now we want to solve for X by hand. So it is still the same thing. How do we get this? You have to get this to be able to solve any problem by hand using logarithms. So we have to divide by 4. That's 11.25. Now we're ready to do log base 2 on both sides. Why log base 2? Because the base is 2. And then the X, you can put the X in front or back. You could do that like that. It just takes it down from the exponent position and puts it as a coefficient before or after. So that goes away. And so whatever log base 2 of 11.25 is, and you actually should crunch this out, again, to keep today as short as I can. So 3, get my answer sheet here, make sure we are indeed correct. So 3.5 is how many days that have gone by. All right, 12 is dealing with this right here. And 12 and 13 are really the same situation. It's just we have an annual rate of computing interest instead of one of these in here. Plus R to the X. So that's the one that we're actually using. We started with $100, interest rate of 15%. So I'm going to do that math. So there's your equation, and 7 years. So how much do you have after 7? And trying to get the note shuffling right here in my presentation, 266. Realize, although I'm not going to go to the graphing calculator today, this is also all table work. If you can create the function, you should be able to see when X is 7, Y is 266. Absolutely, positively. Same way here, you should be able to figure out, you should be able to do your table settings, which I'll probably show this tomorrow, how that works, and we'll just stick to the work by hand today. So now this is where you let Y equal that, and now you're going to solve for X. So don't forget, you need to divide out, you need to get that single base. So we need to divide by 100. Now it's ready to do log base. So you have to really focus on, you can't do log base until you have it like this, or if it's on both sides. You have to have just the base, no coefficient there, and then the variable power. So log base of 1.15. This time I'll put X in front here. And we know again that that is just 1. So what is log of base 1.15 of 5.35? That is about 12. Again, if you don't have the log base, you're doing log of 5.3503 divided by log of, this is a change of base formula, 1.15 into base 10. Okay, so know that change of base if you don't have the log base key. And 13, I'm going to jump right to the substitution here, is using this with n being monthly. So n is 12. So we're going to have 1 plus 0.05 over 12 to the 12x. And if you want to, let's do that. Let's simplify that down a little bit. Oh, that is pretty ugly. I'm going to leave that, the big long decimal there. So we'll leave that as is. And we want to know after 3 years. So you're going to put 3 in for x. And then come up with the value, and that is $2,738.90. It's pretty easy when you don't have to do log base. And then, of course, on part B, you need to this is where calculator skills will come in handy. I probably gave too hard of a problem here calculator wise, but you can actually just enter this like as an answer and then go and grab it. So the steps with this are very, very decimalish, we'll say. So you need to divide it out first. That's that value. And then you're going to do so whatever this is, and I'll again approximate it just to have some work to show. 1.004 and some change to 12x. So you got to do log base 1.004 of both sides, and that's what 12x would equal. I'll actually show you how to do this. Okay. I don't know if it'll grab that. Not sure that this will work here. Okay, I put it right in there. That's good. Just press enter. So there's that long, ridiculous. Oops, I was off screen a little bit. You can round it. I mean, I would accept. So 5.5. You can just say 1.004, 1.31, just for the sake of moving on. This was 66. So 5.5. Yours is X. So just round it to 2 or 3 places is good with that. And then 14 is actually new because we are using the PERT equation, although I like the top one better because it sticks to what we need to do. So A times the natural exponent, and then R x. So actually on A, we're going to use log base first, and then on B, we're going to just crunch out, x is going to be 10, we're going to crunch it out. So we have initially that's A, and then 150,000 is Y. Times E to the R times 7. So that's everything we know. And to get at the variable R, we're going to have to divide to get E, just that single statement alone, just like this again. We have to get the E to the R alone. And then we do log base E on both sides. And then I will be done. And I know I went much longer, but some things just take time. So there's that division. We'll call it 9.68. I will round it, and we'll make this a 7R, something like that. Move the 7 in front. And you got to do log base E on both sides, which is ln again. And log base E of E, and that goes away. So R is log base E of 9.68 over 7. Again, that's ln. And let's see here. Okay. Ln of answer over 7. About 0.32 is the R value there. I'd consider this a tier 3 also, by the way. We'll spend a little time with it. And then what you want to do here is the 0.32 goes in for R. Now this is the main equation that would cover all situations with this. And so now we're ready to put in values of x, or given that y value, figure out what x would be. I forgot to mention this. You need the word continuous to use the PERT formula here. It's got to have continuous. Just meaning that the growing is exactly that. So we have an x value. X is 10, and we just need to crunch it out. The 0.32 times 10. And again, calculator, your E button is generally behind your ln key. So you got to do second function ln in the grapher, and I will show the other calculator also. You can also graph this. So 380,254. But you're going to have to know where your E button is. And on this one, it is right here. That little E box, the 10 box there. So on this one, I think, again, this calculator is very easy. You just tap it once, 0.32 times 10. It's very easy to use, other than it doesn't graph, but it will give you a table. So something to think about. Same way with log base, you just tap the log button 3 times and you have log base. That's very easy in what we need to do. Okay, so you have your assignment. I know I went longer than I should have. And on Wednesday, if you have questions, I will be available.